My name is Aiden Lundberg, and I'm here today to talk about using AI and ML to study wildlife populations in Año Nuevo. I am based in California at Los Altos High. Okay, so I've been working with some researchers at Año Nuevo, which is a Californian state park, and we've been working in order to find a better method to count elephant seals. Now, this is because previously they had two main methods that they relied on. The first being ground counts, which required the researchers to actually go to Año Nuevo, get on the beach, and there's two main beaches, the island and mainland, so they would have to get on these beaches and they would have to count the seals by hand, which disturbs the seals and is very time consuming. And the second method is an aerial count, which they use a DJI drone. However, while this doesn't disturb the elephant seals or any of the animals at Año Nuevo, as they tested and they found that above 40 meters, the drone doesn't affect the wildlife, it does take a lot of time as this drone photo flying at that height. The actual elephant seals, because there's so many and because they're so small, there has to be multiple iterations of human count in order to make sure you get an accurate count. So my goal was to make a fully automated model that can classify and count these elephant seals from these drone images. And the main goal was to do this with female elephant seals, as those are the most important to count the elephant seals population, as the babies and the males, there's just too few males, and for babies, not all of them are necessarily born by the time we take the drone photos. Some of them could be hidden and some of them can die. So female is just the best one overall. Okay, so the program worked in three main stages, and I'm going to go through them now. So the first one is pre-processing. This starts with the raw photos from a drone, the drone that they have, and these photos are given to me by them. Then you can either create the orthophoto using ODM, which is Open Drone Map. That's an open source thing. I'll get more into all my stuff, which is all open source later. But you can either use ODM for this, or you can use Photoshop. The only reason you would want to use Photoshop is if there was just not enough key points, which is what ODM uses. Photoshop also uses key points. However, ODM uses more key points in the photos to link the photos together. So yeah, and this linking is to create an orthophoto, which is what I want to end up with from the pre-processing. So this orthophoto is just a combination of all the drone photos. And then I tested with reducing shadows and image augmentation, which would be done at this stage as well. So you would reduce the shadows in the orthophoto using Photoshop. I used Photoshop as that is free to me because my school provides me a Photoshop account as I'm in digital photo. So yeah. And then you take this orthophoto, you will open it in Label Me, which is another open source site, and you can manually count the elephant seals and you can manually label them as male, female, and baby. And this is just to get all the human data in so the model can actually train. After you're done with that, you click save, and a JSON file as well as the orthophoto will be there, and that's the end of the pre-processing. So next is the training. You can actually see Label Me up here on the next to the training. You see that little box that is Label Me. That's what it looks like. So the training starts with the pre-processing data, the orthophoto along with the JSON file. You put it into the program and it will cut tiles 640 by 640 with no overlap. This is to ensure that the model learns what a seal is, even if it's just like half of a seal. It will still check that seal, still will learn what that looks like. But yeah, so there's no overlap, 640 by 640 pixel tiles, and the orthophoto will take the model will take the orthophoto and cut it into these tiles. Afterwards, the tiles, the labels in the JSON file will also be paired with the actual cut tiles. So each tile has the matching labels, and then the labels are transitioned or translated into the YOLO format. And this is because I use YOLO models. You only look once, and which is just yeah. This is just because I tested it. It's industry standard. I use a YOLO v8.2 model. I tested against a bunch of other YOLO models and it worked the best. So it will convert the labels into a YOLO format, and then the model, the YOLO v8.2 model, is trained on the 640 by 640 tiles alongside the labels. Afterwards, the model will be trained and it will output a validation result as well as a trained model. Okay, so the last step, which is just inference / predictions. So there's two main ways this goes about, um, and I'm going to start with the first one. I'm going to start with the one that's covered by the model that you can see, the diagram. So it starts with the pre-processing orthophoto and as well as the JSON file alongside a trained model. And this JSON file should be the human counts. And then it will do very similar to the training, and it will create tiles from the orthophoto with matching labels and run prediction on these tiles using a model. Afterwards, it will, oh, by the way, these tiles have overlap, and I use intersection over union to get rid of duplication. But yeah, so the model will run predictions on the tiles, and then it will compare the human results to the model results, the predicted results to the human results, which should be accurate, like 100% accuracy, have 100% accuracy. So compare these two models, and it'll output a confusion matrix and a JSON file of the predictions for label me, so you can check it out and see how accurate the model actually is. The other method, which is to actually use the model for predictions, because you don't want to have humans have to count it before you use the model, otherwise it's pointless. It's the same thing except for you just don't put in a JSON file. So you'll just put in an orthophoto as well as a trained model, and the model will cut up the tiles and then it will make predictions, which you can open and label me as it gives the labels in a JSON file. So let's go over the first results. So you can see the table here, and it shows that for the females, which is what we're the most interested in, for both the island and the mainland, there is a very high accuracy. Um, and for the island, for the mainland overall, there was a very high accuracy for both male and baby as well. However, there is an issue with the pups and the males in the island, and this is because I checked on Label Me, and this is because there was a lot of shadows, which made the model train on the wrong, basically train on the wrong seals. It didn't get the correct data, and this data is the validation data, validation results. So it didn't work as well on the island because there was shadows and because there's just in general less data. So the model had less time to actually learn what a male and a baby or a pup elephant seal actually looked like. And I wanted to fix this, as despite the model working, and this did work very well, as it worked well for females, which is the most important one, there is still a clear issue. So I briefly mentioned image augmentation earlier. This is what I did because I noticed shadows were harming my data set. Well, not harming my data set, that's the wrong wording. They were decreasing the accuracy of the model to a substantial amount. I used Photoshop to reduce the images, reduce the orthophotos shadows, and train the island data on that. So here's the settings I used, and here's what it looks like, a part of an orthophoto image that is without shadows and with shadows. You can see the without shadows is a lot easier to see, and you can actually see the seals. And in these two images, this is human data, so that's why they look identical. So the results were a lot better. I'm going to get onto that for the next slide, but first there was one small small issue. For the shadow reduced model, it actually performed better on an unenhanced image for one case than it did on the enhanced image. And this is because the overall orthophoto had little to no actual shadows and there's no seals and shadows. So the only thing that ended up happening is the shadow reduced model, when it was looking at a shadow reduced orthophoto, the shadow reduced orthophoto actually ended up taking away clarity. As you can see here, this is validation data, but you can see here, this is a shadow reduced model looking at a shadow reduced, and then the other one's a raw model, which is just not shadow reduced, looking at a raw orthophoto. So you can see for the shadow reduced model, the male, which is the seal in the middle, the biggest seal in the middle, is actually mislabeled as a female. And this is because there's just less depth in the male, it is lighter, and that caused the shadow reduced model to be inaccurate. Whereas for the raw, despite being a lot less accurate overall, it still did better on the male. It still got the male correct. And this didn't actually apply that often, but this is just one thing I wanted to show that image augmentation can't just be used mindlessly. You can't just use it for everything. So the overall results for image augmentation were very positive. This is also validation data, and you can see this is from the island. You can see that in comparison to the pup and the male, the shadow reduced model did a lot better with a 94% accuracy compared to 68 for male and 100% for pup, which is unusual, but I got a bit lucky for shadow reduced, and a compared to 87 with raw. And you can see the shadow reduced slightly increased the female accuracy as well, which is still important. So I also I want to use this idea, this model, because my model and my program can be used for basically any animal as long as you have drone data and time to basically just label data. You can use it, and I'll get more into how you can use it in a little bit. So I wanted to train it with another animal. However, the issue is I did not have access to sufficient data. So I tried it with sea lions. However, I only had one orthophoto of data, or one beach, which is just not enough for both training, testing, and validation. So it still showed that shadow reduced helped a lot, as there was a lot of sea lions in shadows. However, I mean, it ended up with 86.7% accuracy for the best model, and this is validation data, as you can kind of see. But it just shows that shadow reduce still helps, and I think it shows a bit of potential of the program. However, ultimately, this is inconclusive and isn't enough to say the program can be widely used, despite my belief that it can. So, let's talk about the current use cases that I believe it can be used, and as well as some technicalities that it has. So I think it can be used. I know it can be used for any animal that's just any animal, plants, or even structures from overhead photo. The only catches are it has to be from a consistent angle. You can't just switch up the angles where it's being taken. Otherwise, each time the model thinks it knows what the animal looks like, it will never be able to learn what the animal actually looks like if you have different angles when you're looking at the animal, unless you just have a ton of data. Um, and there's some other catches are that the animals can't move in between the photos, otherwise the program will just naturally overcount. Humans will overcount as well, but like you can't have a like buffalo be in one photo and then have it just happen to move and then it's in another photo. There's no way the program can catch that. There's no way a human can catch that, and that just causes overcounting. And the animals need to be visible for humans in photos. Otherwise, the program's not going to probably be able to learn what the animal looks like. However, some benefits of the program is that it can be run and trained on a laptop, and it can be run all for free. So everything I used is open source, or is available open source. As I said, I used Photoshop. However, that can be instead you can use ODM, which is open source for orthophoto creation, and raw therapy for shadow reduction. All my code and program is on Google Colab, and that has free machines for anyone to use. And all the labeling I do is done on LabelMe, which is also open source. So everything I do can be used for free easily on Google Colab. So there's no paywall, and it's pretty quick. Now, some features for the program is with pre-processing, you can do image augmentation to improve the accuracy of the model. And then after you're done training a model, you can have it run predictions, and then a human can look through the LabelMe, say, oh, it got this, and this wrong, and the model can be retrained on the new, more accurate JSON, the new, more accurate, labels. So the model can be retrained. And some stuff I'm looking into the future is geolocation data. I already had this for my previous program. However, that is not in Google Colab. That is in AWS. So I'm trying to move it to Google Colab. And then also I'm hoping to add direct support for local files, as this will allow people to basically use the program offline. And this will just require me to make it so the program no longer is linking to Google Drive. So what I'm looking for the future is I'm trying to explore new image augmentation techniques to prove the model's accuracy. As you could see from this presentation, shadow reduction really helped my model, so I'm looking for more methods to help improve the accuracy, as well as testing new models. As I said before, I tested YOLO models, but I mainly tested YOLO models like YOLO NAS, YOLO V10, and YOLO V8, 8.2, and some other ones, but those are the main ones. So there's other models and transformers that I want to test, like lightweight DITA and dyno DITA. And I also want to compare the current model's performance to future models, as I know most likely YOLO v11 or maybe even YOLO v8.3 will be more accurate than YOLO v8.2. And I also am looking to test my model on more animals. As I mentioned with the sea lions, it is not enough data to show that the model works with other animals. So I'm looking to use these public datasets called WADE dataset or the Area Wildlife Image Repository to prove that the model actually does work with multiple animals and isn't just limited to sea lions and labeling, not sea lions, elephant seals and labeling elephant seals in Año Nuevo. Thank you so much for listening. This is just I had a presentation of this at a conference called SMM. This is just a at-home presentation to explain what I said to a similar extent and to show my findings without having people finding the actual original presentation and looking through, because it was recorded, looking through all the data and trying to find me. So this is just an easier way to see what I said about in a brief manner. However, it's not out yet, but when the recordings are publicized, I will probably add some way to find what I like my actual presentation, and show how I presented on a big stage. So yeah, thank you so much for listening. This is my contact. Please contact me if you just want to talk or have any questions. Yeah, have a good day.